slope-intercept form, or y equals mx plus b. And when we looked at this equation, y equals mx plus b, we were able to identify what the slope was, what the y-intercept was, and then we were able to look at a graph and try to figure out what the equation would be. Today we're going to look at a table, and we're going to figure out the equation for the line that's represented on this table. Okay? So we're going to make some connections between the values on the table, what they actually mean in terms of the line, and how the equation comes into play. Okay, so that's what we're going to focus on. And it's a little bit of a shorter lesson because the second half of class you're going to do a little activity on the computers. What information would we need to write an equation?
2 points.
Okay, so 2 points. Would that be writing the equation or drawing the line?
Drawing the line.
Good. 2 points would help us create the line. Ooh, I spelled create wrong. What do we need to write the equation? If we're going to write an equation in slope-intercept form, what information would I need for that? The slope. And the y-intercept. Absolutely. The y-intercept. So I want these two values. So let's find the slope. By definition, what is the slope? The steepness of our line. Good. How else do we explain that steepness of the line? Rise over run. Okay, so we've used rise over run. And what does that mean?
Y divided by x.
What about y?
Change.
The change in our y compared to the change in our x. Good. So knowing that that's what the slope is there a way that I can find that in the table? Now looking at the table, we see a bunch of numbers here. What do those numbers represent? What do you mean points? Coordinates. Give me an example of one, Patrick. This set of numbers is a coordinate on my graph. This is where the x value is 2 and the y value is 3. This one here would be where x is 4 and y is 8, right? And so on. These represent coordinates. So how can I use those values to find my slope? How would I find, for example, the change in y and compare it to the change in x? Do you see in that table a change in y?
Yes.
What is our change in y? What's happening in the table?
Y.
Every time I increase by 5. And if you need an example in your notes, this is a great example to utilize. Okay, so we see that from at one coordinate to the other in our table, we're increasing by 5. What's my change in x? I'm increasing by 2. So from this information, how would you represent the slope? If I represent my slope as the rise over the run, or the change in y over the change in x, what would the slope be for this relationship? Ibrahim? 5 over 2. Do we agree?
Yes.
Now notice here, this is our y values, and these are our x values. Yeah, this makes sense. And if I sketched it really quick, and I plotted the coordinate of 2, 3, and then 4, 8, how am I going from one point to the other? I'm actually going up 5 and over 2. Okay? That's where I'm getting my 5/2, my change in y over my change in x. And it doesn't matter. A lot of students are like, do you always have to go from left to right? You don't. And I'll use this example. I'm going to erase a few of these here. What if I wanted to go from this coordinate at 14 and 33 to this coordinate at 12 and 28? What's my change here? What's my change in y? From 33 to 28. I'm subtracting 5. And what's my movement for x? Subtracting 2. So my rise over run for that example is -5 over -2. And what do I have if I have a -5 over a -2? Yeah, +5 over +2. These are actually the same number. And they will be no matter which direction you're moving because those points are all on the same line. And we've learned a few days ago that any 2 points on a line, on a straight line, they'll always have the same slope. And it's okay if you have a table like this to actually show the movement. What kind of line is this? When I showed all of these values, and I kept getting +5, +5, +5, +5, and then my x value is +2, +2, +2, +2. What do I know about that line? What do I know about that line? Think about your terminology. What's it going to look like? It's going to be a straight line. How do you know it's a straight line? Because the rate is constant. Yeah, every x value is increasing by 2. Every y value is increasing by 5. It's constant. If I was working with the table and like this was 2 and the next value was 5 and the next value was 8, assuming these are not equivalent, like 5 over 2 and 5 over 2, if this one all of a sudden was like 7 over 2, those aren't the same. It's not the same slope. But here I can see clearly that the rate here is constant. So we have our slope of 5/2. How are we going to find our y-intercept? Let's talk a little bit about our y. What do we remember about a y-intercept? It's the y value, good, when our line crosses the y-axis. So that's relatively easy to see in a visual if you're looking at a graph. There might be a time where the value's not easy to determine in a graph, but we at least can see it. How am I going to find that value on my table? How would I know where it is? Let's use 2 different lines as an example. This is one line with my y-intercept, and here's another line with my y-intercept. I know a few things about y-intercepts. What do I know about them? What do I know about those points? So those two aren't going through the origin. Could my y-intercept go through the origin? Yeah, that would be a y-intercept of 0. Right. What else do I know about my y-intercepts? We know what they look like. You had mentioned it already. You said it's where my line crosses the y-axis. What does that mean? Because now what we need to do is take that understanding and figure out how am I going to find that in a table. What do you mean divide?
Like, to get to 0.
Why 0?
Because 0 is like where everything starts.
Let's expand on that. You're saying that 0 is where everything starts. It's the first value. On this graph, is 0 necessarily my first value? That's very common, what Laura's saying, that 0, we're so used to 0 being the first. But if we have a line, when does that line ever end? Never. Like, that line's going on forever.
So you're asking, like, when using a table, how to find the y-intercept?
Yes.
Well, I was thinking, like, when I was going from 2, 3, 4, 8,
Okay.
I noticed that usually in my head I'm like, just double it.
Okay.
And then I noticed that from 3 times 2 is not 8.
Okay.
So I know that I had to add 2 to get that. And I wanted to try it out with other ones, but I got distracted. So let's see if it'll work. 4 times 2 will be 8. 8 times 2 is 16. Plus 2 to get 18. So it would be 2. I don't know. I mean, it's working.
Well, our slope here, we increased by, every time our y increased by 5, our x increased by 2, which is why we know our slope was 5/2. But how am I going to find the y-intercept? What does it mean? Oh, go ahead. Let's.
Maybe you can try to lower 4/8. It's like
It decrease 4/8. Now let me ask you this. Is our y-intercept on the table right now?
No.
How do you know that?
because the graph doesn't go to the table.
Because our graph isn't
Zero,
going
one.
into negatives. Where do I want to find it? Think about, look at my two y-intercepts on that graph. What's the same about them? Like this line, this point here, sorry, that coordinate there, and that y-intercept there. What's the same about them? They're both intercepting y.
They're both the same distance from 0.
Well, this one's 2 and that one's 3. So they both cross the y-axis, but there's something else. Make the connection between the visual and the numbers that it represents. What does it mean that they're crossing the y-axis? They are y-intercepts, but what more does that mean?
Looking at them, you said that one's 3, that one's 2. That equals 5.
Okay, so that y-intercept up here is 3. That y-intercept is -2. But what about, like, there's something general that they share, two of them, and really any y-intercept, not just those two. I just gave you 2 examples. There's something that they share. What does that mean? Both of the points are on the y-axis, which means what? Keep going. Because think about this. We need to find a value on our table. So what does it mean if they're on the y-axis? Okay.
Dead serious.
Tables are the same.
Which number is the same?
Like
Johanny has her hand up.
What's the same?
I think they don't have zero. Wow. What? They don't have zero at the end.
Their x coordinate is 0. So this y-intercept here is 0, 3. And this y-intercept here is 0, -2. So I know that if my y-intercept is always on the y-axis, any value, any coordinates that is on the y-axis always has an x of 0. So where would I need to look on my table to find my y-intercept? Where what? Where x is 0. Is that on my table right now? No. Can I find it? If x was 0, what would y be? Let's look at this pattern. I increase by 2. I increase by 2. I increase by 5. I increase by 5. So here, I increase by 2 from 0 to 2. So what number must y be if I increase by 5? -2. So to find my y-intercept in a table, I need to find where x is 0, because that represents the coordinate on my y-axis, and that will be my y-intercept. Sometimes it'll be on the table. Other times you might have to find it. But we can actually use the slope to find the value on that table where x is 0. And wherever x is 0, that y value will represent your y-intercept because the coordinate here is 0, -2. Good job. So now let's put it all together because we found the slope of this of the line represented in this table. We also found the y-intercept. Took a little bit of work, but we found it. So now, let's put it together. If I knew the slope was 5/2, and I know that the y-intercept is -2, who can tell me what the equation would be for this line? Got it. Zara, what do you got?
Y equals 5/2 minus 2. Oh, 5 halves x.
There you go. Good. That represents, that's the equation that represents this table. Fantastic. Excellent. Are you writing it down? Okay. We're going to go through an example that I want you to take a look at on the next slide and determine if there is a mistake. But right now, if you're filling this in, I'll leave you here for a second. Anybody else need more time?
She's so excited.
Okay, so here, I'm going to pause it here, but here's what we're going to do. I would like for you to work with the people around you, just bounce some ideas off of each other.